what we could do is create a new function. So I'm going to call this determine market value, and then I'm going to pass it in by val my car as car, and I'm going to return back a money value. And whenever you're dealing with monies, you want to deal with decimals, the decimal data type. Okay, so when you're dealing with money, you want to work with the decimal data type. It's like integer, except it allows you to have values after the decimal place. And so in this case, what I could do is do some super secret formula here to figure out what the value of any given car is. I could even go and search online to find the value of the car, but we're not going to do that. Instead, I'm just going to hard code and return, I'm going to return the value of 100 for the car. So we're going to pass in my car. We're going to do some evaluation on it. We could like retrieve its properties here, mycar.make. So maybe we'll do that in a future example. But we could evaluate it, pass it to something online, get the value, and then return it back. So here, if I were to, let's comment this out. And let's just do this. My car, let's go determine market value, and we'll pass in my car. All right. Then we'll see what the current value of my car is. All right. You can see that it's 100. Let's go ahead and format it like currency, right? So I use the :C formatter. Now we can see the value of my car is actually $100. All right. So the point here is that we can use now this data type car that we define just like any other data type, integer, string, date, whatever, and we can use it as input or as return values from functions that we create. But there's maybe an even better way to do this. Let's talk about creating methods inside of our class definition. So I said before that a class is really just a container for your methods, but I haven't shown you any methods. I only been talking about the properties, but we can also create methods inside of our classes. So let's do that. Instead of putting that determine market value here as a function that we pass the car into, we should be able to just create it here inside the class. It will have access to all the data that it needs in order to make the determination, so we shouldn't have to pass in anything. We'll just say, let's go just public function market value as decimal. Okay, so we're not passing any values because we're going to be able to access the attributes of this car. So let's go ahead and we could do something like, the super secret formula right here. We could actually look online for the value and then return it. But what I'm going to do is something a little bit different. We'll just write some really crazy logic here to determine the car's value. So I'm going to create a car value as decimal. This is ultimately what I'm trying to determine. I'm just going to create a variable that'll hold it. And now what I want to do is find out the current year of the car. Now I could just type year like that and it would work. But what I would really prefer to do is to say not just year, because year, where did this come from? Is this just some, it might be difficult to remember the properties of a car. If I were to look at this in the future and say, I don't know, I'm looking at this function, it's not clear to me where this year word came from. So what I can say is for this instance of car, this current instance, give me the year attribute. Now I prefer doing that. Clearly, Visual Studio would say, well, you could probably simplify this, and it gives me the little light bulb under it, and it said just remove the me qualification. All right, so we'll just go ahead and leave it off. But remember, if you want to reference this specific instance of the class and retrieve its attributes, its year, its make, its model, then you can use the me dot. All right, but we'll get rid of it. So at any rate, if the year is greater than 1990, then the car value, we'll just hard code it to $10,000. Otherwise, if it's older than 1990, then we'll make the car value just $2,000, and then we'll return the car's value, like so. Okay. And now let's go ahead and rework this line of code. And we'll just go console.writeLine. In fact, let me just borrow almost everything inside of here, except we'll change how we make a call. And in this case, we're just going to go mycar.determine mycar.market value. Okay, I thought it was called something else. And so now I'm going to be executing a method, so I have to use the method invocation operator on it. It's not a property. Properties, I don't have to use the method invocation operator. Even if I try to, I'll probably get an error. All right, it lets me do it, but again, that's only because Visual Basic is very forgiving, and I can probably leave it off here too and it will still work. But again, I want you to be purposeful and think about the usage of a property versus a function, or rather a method. Let's run the application, and you can see now that our Toyota is worth $10,000. All right, so what do you make of all of this? Well, in this lesson, we used a very concrete example, the example of a car. And a car is easy for all of us to conceptualize. It's tangible. There's a real-world equivalent. We can think of what a car really represents in the real world. We can model it fairly easily because we know the attributes of a car, just like we know the attributes of, a pad of paper or whatever the case might be. Now, you're going to be building applications, especially in this series of lessons, and typically you're not going to be responsible for creating your own custom classes. I think your main exposure to classes will be what we've experienced so far, which is those classes, again, which were created by Microsoft and available in the .NET Framework class library. In most of those cases, the classes that have been defined in the .NET Framework class library do not have real-world equivalents, like something tangible, like a pad of paper or like a car that we can sit inside of or touch. In other words, the classes inside of the .NET Framework class library are more conceptual in nature. For example, I might work with a class that represents a connection to the internet. Or I might work with a class that represents a stream of data as it's being streamed into me from some other source, flowing from one place to the other like a pipeline. And we already saw that there were objects like a span of time. It's difficult to put your hands on time, right? But there are objects in the .NET Framework class library that represent a span of time between two dates, okay? So very conceptual in nature. In these cases, we're not working with something tangible that we can touch and we can feel, but we're working with something, again, a construct of our own minds, or something that is that we can't touch inside of the computer. Now, as you mature as a software developer, you might want to invest more time in learning how to create your own library of classes that interact with each other in some meaningful way as a means of breaking down real-world problems into conceptual problems and turning them into code by abstracting their features, their most identifiable features that are important for your application, into a series of classes, okay? And that process that you go through to turn something in the real world into something conceptual is called object-oriented analysis and design. And that's not something that we're going to cover in this series of lessons. You can spend years learning how to do it properly, but I do have some courses on devu.com that will help you learn that if that's something you're interested in. I spent a lot of time actually thinking and talking about object-oriented programming there. So, all right, to recap, a class is a data type, just like any of the data types that we've learned about up to now. It's similar to those basic data types like integer and string, and it's also similar to those complex data types like console and random that we've used up to this point in time. And you can define a custom class with properties, as we saw here, and methods, like we saw here, and we can actually then utilize them by creating new instances of a given class and then using the member access operator to either set or get the properties or to call the methods that have been defined on our classes. And inside of those methods, we can access the various attributes of this instance of this given class, and then make and create business logic around it to, in this case, for example, determine the value of the car. All right, so don't worry. I've got a lot more to say about classes. If you don't understand everything there is to know about classes just yet, why you need them, that's okay. Don't fret about it. Just make sure that you understand the process that we went through to create a new class, how we created properties of the class by using this syntax, public property, then the name of the property, and then as whatever data type that we want to make that property. Understand the purpose of when we typed in prop tab and we were able to create the full version of a property, and we see here the get versus the set for that property. How we created a method. We could have used a sub. We used a function because we wanted to return a value, but again, how we created a method inside of a class, and then we were able to access that either property or method by using, again, the member access operator for a given instance of our class. And if you understand just that much, then you're doing all the right things up to this point. We'll fill in more details in the coming lessons. So if this didn't make sense, there's nothing wrong with watching this video a second or third time, or even watching other videos that might help you better understand classes. But do this, stick with this. Don't drop it right here, even though we're at a conceptual hurdle for you. A lot of people have a challenge with this, and don't make it harder than it really is, at least not at this point. Okay, so you're doing great. Let's continue on to the next lesson. We'll see you there. Thanks. Hi, I'm Bob Tabor with Developer University. For more of my training videos for beginners, please visit me at devu.com. In this lesson, we're going to continue on with classes and object-oriented programming. We're going to talk about the lifetime of object references and how .NET manages the memory that your objects use. Secondly, we're going to talk about constructors, which are special little methods that run at the moment you create a new instance of a class, and we'll talk about why you even want to use constructors. And then finally, we're going to talk about shared methods and properties. Shared is a keyword. In other programming languages, it uses the term static, meaning that you can use that particular method or property without creating a new instance of an object first. So that would explain the console window and its difference from how it's different from the random object that we used in previous lessons. So let's go ahead and get started. And this is one of those cases where you probably want to use the code that I'll supply. You can find it wherever you're currently watching this video or wherever you originally downloaded it from. There is a folder called Before, and you should be able to find in the Before folder an object lifetime project, and you want to copy that somewhere on your hard drive. I'm going to put it where I put all my projects, here in the project subfolder of Visual Studio in my documents directory. Okay, so now let's double click the solution file to open up Visual Studio, and you'll see that I've already pretty much just copied the code that we worked with previously here to create a car class with the make, model, year, and color. And then you'll notice also in the module VB in the sub main, we're creating a new instance of the car, setting its attributes, and well, there's a little bit of something that we'll come to a little bit later. Let me go ahead and delete that for now. All right, so at any rate, what I want to do is actually focus on this line of code, line number 5. What's actually going on here? Well, the .NET Framework runtime, when it encounters this line of code, will have to go and create a spot in the computer's memory large enough to hold a new instance of the car class. So that's that bucket analogy we've been using. It's going to create a new bucket in the computer's memory large enough to hold a new instance of this custom class that we created, right? So the computer's memory has addresses in it, similar to the address where you currently live in your home or apartment. So admittedly, the addresses in a computer's memory looks a lot different than the address you might live at, 123 East Main Street, some city, some country, and then some postal code, right? It actually uses hexadecimal values as addresses, but they're addresses, they're known addresses nonetheless. And that's how the .NET Framework runtime knows where it put your buckets. It keeps track of the addresses, and it keeps track of the address and the little friendly label that you give it whenever you create a new instance of a given object. In this case, my car is at this address. It uses that address, looks up into that address in the computer's memory, finds the bucket, grabs the values out, and lets you work with them. Okay, so the .NET Framework's first job is to find an empty address where nothing else is being stored right now whenever you create a new instance of an object. And so that address has to be large enough in size to store a instance of our given class. So it creates the object, and then it grabs the address of that object and copies that address down. And so it always knows where to find that object in memory that we've labeled my car in this particular situation, so that you can always get back to that object in memory. And so you can store that reference in your variable, but really all you're doing is storing an address in that variable. And behind the scenes, the .NET Framework runtime knows what it means. It goes and finds the actual bucket at that location. Okay, so my car in this case is simply holding an address, or what we would call a reference, an object reference, a reference to the instance of the car class in the computer's memory. So whenever you need to work with that instance of the car class, you just use the myCar identifier. We can set and get attributes, we can call functions, and the .NET Framework takes care of the rest for us. Awesome. So it gives you this illusion that you're actually working with the object itself, but in reality, you're just holding onto a reference to an address in the computer's memory, and then the .NET Framework runtime takes care of all the rest and makes it hidden from you. So an analogy that helps me understand references to objects is kind of, maybe to extend the analogy of a bucket, a handle on the bucket. We've used the bucket analogy several times up to now. So whenever you store an object in memory, .NET gives you, the developer, basically a handle that allows you to get back to that bucket, so you can hold on to that bucket. All right. So what happens if you let go of the handle? Well, you'll no longer be able to get to that bucket. The bucket will no longer be accessible. Why will it no longer be accessible? Well, one of the missions of the .NET Framework runtime is to keep the memory region clear and get rid of stuff it no longer needs. And so the .NET Framework runtime goes through and cleans up memory every once in a while, and it does that by counting references, or counting how many handles you're actually holding on to. So if we're no longer holding on to a reference or handle to that particular object in the computer's memory, to the car class, then it's going to remove that instance of the car class from the computer's memory because it thinks we don't need it anymore. So it frees up that space in memory so that other programs can actually use that for their own needs. So this process of cleanup is called garbage collection, and there's a lot you can learn about garbage collection and how it works behind the scenes. Not all that important for the moment, but what I want to do is actually run a quick experiment. And I want to actually use that line of code that I accidentally left in a moment ago. So my other car as car equals my car. All right, so here we go. At this point now, we did not create a new car in the computer's memory. All we did was say, I want to create another handle, and I want to attach that handle to the same handle that my car is pointed to. So we essentially just copied the reference from my car to my other car. Now we have two handles attached to the bucket in the computer's memory at this point, okay? And to prove this, here, let me just show you how I can prove this. So console.writeLine, and we'll go my other car dot make. That should be sufficient to prove this to you. Then what I'm going to do is go my other car. I'm going to set the color from whatever it is to black. And then what we'll do is console.writeLine, we'll go my car dot color, and just to see what color it is. Is it still white or is it something else? So this should prove that we're now dealing with two handles to the same object in the computer's memory. So let's also write a console.readline real quick here, and let's run the application. And you can see the first thing we get printed out is Toyota. So that was what we got from my other car, even though we never set explicitly the make attribute of my other car. Because it's referencing my car, it's able to grab out Toyota. And then next, we're looking at my car. We set its color to white, but since my other car is pointed at the same object in memory, we can set it to black, thus affecting the color of my car and setting its color to black as well. All right. So now you have two references to the same object in the computer's memory. And I think the important thing here is that you can create a variable that can hold a reference, but you don't have to create a new reference necessarily. You can just copy the reference from another object. All right. So another analogy that kind of helps me is, because you don't think about multiple handles on a bucket, maybe you could think of it like strings on a balloon. After you cut the last string on a balloon, what happens? If it's filled with helium, it's going to float off into outer space and you never hear from it or see it again. All right. So the same is true whenever you're working with references here in your application. When the references go out of scope, in other words, whenever the current thread of execution of our application exits through the end sub, and it leaves the code block where the variable and the object, the variable holding the reference to the objects in memory are actually defined, then we actually lose those references. We're essentially cutting the strings off because we're exiting out of the application, or at least out of the scope of this method, and those variables are no longer accessible. The .NET Framework comes through and says, oh, hey, car class, it looks like nobody's looking at you anymore. Time for you to go away. And so it takes it and removes it out of memory. All right, so that is known as reference counting, to see how many references are still attached to a given object. The .NET Framework will count the references. If the references go to 0, the count goes to 0, then it will remove that object from memory. So at some indeterminate time in the future, after we exit out of the execution of our application, then the .NET runtime with garbage collection feature will come around and will count references. It'll remove the objects in memory, freeing them up for other applications. Now, what if we wanted to explicitly remove our references? In other words, what if we explicitly wanted to cut the strings to the balloon before we go out of scope, because we hope to use that particular variable again, or we're working with a lot of objects and we want to free up the memory? We can actually do something like this. So here I'm going to set my other car equal to nothing. All right, so when we set this equal to nothing, we're saying, hey, instead of pointing at something, point at nothing. So now if we were to try to reference and go console.writeLine and go my other car dot, and we attempt to get the color out, let's see what happens when we run the application. We're going to get an exception that there's a null reference exception. There's a reference, but it's null. In other words, we don't know what it's pointing to. It's pointing at nothing. So we can't access an object that is pointing to nothing in memory. All right, let's go ahead and stop that. Now, if we were to set both of these to nothing, so my car equals nothing, we would actually probably kill off this line of code as well. And then at some future point in time, some indeterminate point in time, the object would actually be removed, but it doesn't really matter from a practical purpose because we don't have any access to that object in memory anymore. So in some situations, this indeterminate amount of time, because the garbage collector will run whenever it feels like running, there are some rules and memory pressure that force it into action, and otherwise it will just be dormant. But if we need to be specific about removing objects and we want to be explicit about removing objects from memory because we have a very memory intensive application, we can do something called a deterministic finalization approach that allows us to say, hey, stop everything you're doing .NET Framework runtime and remove it now. And we might want to do that in situations where we're holding on to some connection, maybe to a network resource, to a database, to a file, and we want to sever that and make sure that at the moment that we say we want it to be severed, we want it to be actually severed so that it frees up that resource so something else can actually use it. So that might be a scenario where we would want to be very specific about it removing that object from the computer's memory, but otherwise we can just let the .NET Framework do it on its own and not really worry about it. That's a little bit more of an advanced concept. We're not going to cover that in depth in this series of courses. However, if you were to search for the words deterministic finalization online, you'll find some articles about it out on MSDN, maybe even some videos. All right, so the next thing that I want to do is focus on the little subtle usage of the opening and closing parentheses, because hopefully there's something about that should jump out at you. And that little something is the fact that we're actually using the method invocation operator here whenever we create a new instance of a class. So whether you realize it or not, whenever we create a new instance of a class, like the car class, we're actually calling a method called a constructor. And it allows you, the developer, the option to write some code at the moment that a new instance of our class is instantiated, that moment when that new instance of the class has been created in memory. We can write code at that point to do things like, for example, put the object itself into a valid state, just like we would any other initialization that we've used for other variables or even the array, as we learned earlier. So this means that we can use our the special constructor method to construct or initialize the values of properties so that our objects are ready to be used on the very next line of code. You may not always be able to do it that way, but it's definitely an option to use. So I want to create a quick example here of why you might create a constructor. And that'll allow us to set the properties of the car at the moment whenever we create a new instance of the car. So to create a constructor, you use the public sub and then the new, and the new keyword represents a constructor. So here I'm going to do something like maybe I would load this from a configuration file to populate the make, the model, the year, and the color. I might actually load it from a database, or maybe grab it from online somehow. But in this case, what I'm going to do is to actually hard code the make property so that by default all new instances of the car class will automatically be or have its make property populated with a real value. All right, so here what we'll do is just say make equals, and then we'll say Nissan. Okay, so now whenever we create a new car, what we can do right away is console.writeLine and then look at my car dot model, or was it make? I think it was make, sorry. And you can see that initially, by default, the car is in a valid state, setting its property to Nissan. Of course, then we cover that up by setting it equal to Toyota and print it out a little bit later, but at least you get the idea of how you can use it. Now, admittedly, this doesn't make a whole lot of sense right here. I'm just showing you the technique that you would use, not really the rationale. But let me show you an overloaded version of a constructor. So like you created an overloaded method in one of the previous lessons when we talked about methods,